And now in this video, we're going to do F and G. And I kind of went over this when I talked about exponential functions. But remember, if there is a negative attached to the variable, that is a reflection over the y-axis. And if there is a negative in front of your function, that is a reflection over the x-axis. So we're going to apply that. But this time I'm not going to write it down because I already wrote it once. Now, because here we have a negative attached to the variable, we're going to reflect the function across the y-axis. When I reflect across the y-axis, I change the sign of every x coordinate. So in this case, to sketch g of x, which is going to be log base 2 of negative x, that is just the graph reflected across the y-axis. So let's go ahead and do that and reflect every point across the y-axis, once again changing the sign of every x coordinate. This first point that I have right here, this is the point of 1/4 and -2. When I reflect that across the y-axis, that's going to become -1/4 and -2. This point right here is 1/2 and -1. Reflect that across the y-axis, that becomes 1/2, well, -1/2 and -1. And then we have the point right here, which is 1, 0. Reflect that across the y-axis, that becomes the point of -1, 0. And remember, once again, you're changing the sign of every single x coordinate. Let me erase my line. The next coordinate we have is going to be the point of 2, 1. Reflect that across the y-axis, that becomes the point of -2, 1. We have the point right here of 4, 2. Reflect that across the y-axis, went too far down. That's going to be -4, 2. And then the last one we have here is going to be 8, 3. Reflect that across the y-axis. I'm not going to get too accurate for that one, but that's going to be the point of -8 and 3. We can erase that. Let's draw that line to the best of our abilities. This one's going to be kind of hard. Okay. I'll leave it right there. I tried my best. But yeah, this will be the function g of x equals log base 2 of -x. We reflected every point across the y-axis, changing the sign of every x coordinate. Let's find the domain of that function. Domain is the set of all possible x values for the function. Look at the left side of the function. This function goes forever and ever and ever towards the left, which means the x values are decreasing indefinitely. And when x increases indefinitely, that is approaching -infinity. So this right here is going to be -infinity. Start from -infinity and come all the way, moving more and more towards the right. This function right here is approaching the y-axis, but is not touching. When a function is approaching the y-axis or not touching, that is an asymptote. The y-axis has an x value of 0. So the function is approaching the x value of 0, but it is not touching. That is my domain. The range of a logarithmic function is infinite, -infinity, +infinity. And because, once again, the function is approaching the y-axis, which is the line of x equals 0, my vertical asymptote is x equals 0. So we sketched the graph and we stated the domain, the range, and the vertical asymptote. Now, let's do the last one, which is a reflection over the x-axis. And when you reflect over the x-axis, you're changing the sign of every y-coordinate. So, this point right here is the point of 1/4 and -2. Reflect that across the y-axis, the x-axis, that's going to be the point of 1/4 and +2. Once again, you're changing the sign of every y-coordinate. This right here is the point of 1/2 and -1. You reflect that point across the x-axis, that's going to become 1/2 and +1. This coordinate right here is the point of 1, 0. That is on the x-axis, so I cannot reflect it. So I'm going to leave it the way it is. The next point is the point of 2, 1. Reflect that across the x-axis is going to become the point of 2, -1. You have a point of 4, 2. Reflect that across the x-axis. That becomes the point of 4, -2. And then this point right here is going to be 8, 3. Reflected across the x-axis is the point of 8 and -3. Sketch that function to the best of your abilities, and I will do to the best of my abilities. Nope, let's retake that. All right, I hope that's better than the first one, but it's not, but I did it. So let's just keep it as h of x equals to -log base 2 of x. Once again, we reflected the graph across the x-axis. You change the sign of all the y-coordinates. Now, let's find the domain, the range, and the vertical asymptote. Domain for this function. On the left side of the function that's sketched in black, it is approaching the y-axis. Once again, remember, the y-axis has an x value of 0. So the function is approaching the x value of 0, but it's not touching. That's going to be the lowest value of x. Now, although the function is going downwards in this case, but down here, the function is going forever and ever and ever towards the right, which means the x values are increasing indefinitely. And when x increases indefinitely, it approaches positive infinity. So my range, I can't write my zeros correctly, but my range goes from 0 to infinity. So my domain goes from 0 to infinity. The range of a logarithmic function is infinite. And last but not least, the vertical asymptote is x equals 0. Once again, the function approaches the y-axis. The y-axis has an x value of 0, does not touch, does not cross, thus that is going to be the vertical asymptote. And that is it. That is it to sketching your logarithmic functions. So guys, hope that made sense. Hope you enjoyed part 3 as much as I did. Hope you understand it and you be ready for your exam. I'll see you guys soon. Take care.